Welcome to this video on permutation and combination, two fundamental concepts in counting principles and probability. We will cover the basic concepts, formula derivations, solved examples, an algorithmic approach, and real-life applications of PNC. A permutation is an arrangement of objects in a specific order. The key point is that order matters. For example, ABC, BCA, and CAB are all different permutations of the letters A, B, and C. A combination is a selection of objects where the order does not matter. The key point here is that order is irrelevant. Choosing A, B, and C is only one combination, regardless of the sequence. The main difference is that permutation involves arrangement where order matters, while combination involves selection where order does not matter. Keywords like arranged and ordered hint at permutation, while select and choose suggest combination. The sum rule or addition rule is used when choosing between two tasks, and only one can be done. If one task has m ways and another has n ways, the total ways to do either task is m plus n. The product rule, or multiplication rule, applies when two or more tasks are done sequentially, and both must happen. If the first task has m ways and the second has n ways, both tasks together can be done in n ways. Next, we will explore the derivation of the formulas for permutation and combination. Counting is a basic tool in probability. We will derive the formulas for permutation, which is arrangement, and combination, which is selection, using logical reasoning. To derive the permutation formula for arranging R objects from n, we start with n choices, then n1, and so on. This leads to the formula Pn, R equals n/nr. For combination, where order doesn't matter, we start with the permutation Pn, R. Since order is irrelevant, we divide by the number of ways to arrange the chosen R items, which is R, resulting in Cn GOR at R equals n/R asterisk nr. In summary, the permutation formula is Pn, R equals n/nr, and the combination formula is Cn, R equals n/R asterisk nr. Now let's look at some solved examples to apply these concepts. Example 1 asks in how many ways the letters of the word leading can be arranged so that the vowels always come together. The options are 360, 480, 720, or 5040. The word arranged indicates that this is a permutation question. The word leading has 7 letters. Grouping the vowels EAI as one unit leaves landing plus the vowel group, totaling 5 items. These 5 items can be arranged in 5 factorial ways, which is 120. The vowels EAI can be arranged internally in 3 factorial, or 6 ways. The required number of ways is 120 times 6, which is 720. The correct answer for example 1 is C, 720. Example 2 asks, out of 7 consonants and 4 vowels, how many words of 3 consonants and 2 vowels can be formed? The options are 210, 25,200, 1050, or 21,400. The initial step of selecting items without regard to internal order makes this primarily a combination problem, followed by a permutation step for word formation. First, we select the 3 consonants from 7 and 2 vowels from 4, using combination 7C3 times 4C2, which equals 210 groups of letters. Each of these 210 groups contains 5 letters. The number of ways to arrange these 5 letters to form words is 5 factorial, which is 120. The total number of words is 210 times 120, equaling 25,200. The correct answer for example 2 is B, 25,200. Next, we will explore the algorithm approach to permutation and combination. Permutation and combination are essential in computer science, powering cryptography, data structures, algorithms, and machine learning. In cryptography, PNC scrambles and protects data. Strategies include picking and arranging elements for encryption, transforming and permuting data, or combining special numbers for locking data, as seen in algorithms like AES and RSA. Backtracking is a recursive technique that solves problems incrementally, removing solutions that fail constraints. It relies heavily on generating permutations and combinations. The n-queens problem is a classic example that uses backtracking to find valid queen placements, where the goal involves generating valid permutations and pruning invalid configurations. Dynamic programming, or DP, optimizes recursive solutions by storing and reusing results of subproblems in a table, avoiding repeated calculations. Many DP problems are counting problems, with PNC forming the backbone of their recurrence relations. The path problem, counting unique paths on a grid, utilizes combinations for the total number of moves. In machine learning, permutation tests use PNC to generate randomized label arrangements for model evaluation. Hyperparameter tuning explores parameter combinations, and Bayesian models rely on combinatorial probabilities. Let's explore how PNC shapes everyday choices and creativity through real-life applications. Security systems use permutations for passwords and PINs. A 6-character password has billions of possibilities. More arrangements lead to stronger security for ATM pins, Wi-Fi, and phone locks. Games utilize PNC. Lottery draws rely on combinations where the order of numbers doesn't matter. Card games like poker use combinations of 5 cards, while number games may use permutations when order is important. Daily choices often involve combinations, such as choosing dishes from a menu or pairing outfits. Photography settings also involve permutations of ISO, aperture, and shutter speed. Events and scheduling use permutations. Seating 5 people has 120 possible arrangements. Shifts or speech orders are set using this combinatorial logic for real-world organization. Forming teams relies on combinations. For instance, choosing 3 people from 10 can be done in 120 ways. PNC helps in event planning and group projects, reflecting how decisions are a mix of possible outcomes. In conclusion, permutations and combinations are powerful tools that extend beyond mathematics. They help solve problems, make predictions, and organize real-life situations, teaching us how order and selection influence outcomes. Thank you for watching this video on permutation and combination.